Yesterday, on the back of my phone case, I placed the number 384,615 there. And why? Well, I'll show you some appearances of that number that might make you understand why. So that number appears constantly when I'm working with numbers that involve fractions that are divisible by 13, or specifically 1 over 13. Or maybe those fractions are divisible by 1 over a multiple of 13. But anyway, this number this number is most famous for appearing as 76,923 times 5. And what's special about 76,923? Well, it's if you multiply it by any number up to 12, the digits will cycle between these two numbers. Like, these two sets of numbers, it will cycle between. Like, depending on what number you're multiplying it by, it can cycle from a random digit from this number up top, or this number. And in which case, multiplying by 5 gives you 384615, and it is a rotation of this one right here, 384615. You see it now? And because it's multiplying it by 5, that means when you divide 76,923 by 2, you get 38,461.5. And it still looks a lot like 384615. And I also wanted to mention that when you multiply 76,923 times 13, you get 999,999. That's because 1 over 13 is 0.076923 repeating infinitely. Which brings us to the next one. So, because 1/13 is 0.076923 repeating, that means that 1/26 is going to be 0.0384615 repeating forever. Because it's literally... because 76923 divided by 2 equals 38461.5. And because 1/26 is 0.0384615, 3844615, repeating forever. Like, this is how it goes. Because that is the case, that means that if you were to, like, say if you were to write down 1,000 names, and you gave each letter in the alphabet an equal set of names. Like, if you wrote down 1,000 names, and you were to distribute them equally among all 26 letters in the alphabet, then each letter would... then you'd calculate it to find out that each letter would get exactly 38.4615 names. But that's not quite possible, because you can't have 38.4615 of something. So that's why it's best to look around that number for numbers like 38 or 39, whatever's close to that number. So it's literally going to take you 38.4615 different things for each letter in the alphabet. If you wanted to, like, 1,000 of something, and you wanted to distribute it equally among all 26 letters, then each letter would get 38.4615 of each. That's what I'm trying to say. And then... yeah, and that number also looks like 384615, which it basically is. It's pretty funny. And another appearance of this number I want to tell you guys about is what happens if you take another fraction involving the number 13. Let's make 13 the denominator, and now we reverse 13 to get 31. So this is the reverse of 13. And let's divide these two numbers together, and what do we get? We get 2.384615, 384615, 384615, 384615, repeating forever. That's pretty crazy. And that number appeared so much when working with fractions that involve the number 13 that I decided, why not just put it in the back of my phone case? That way, people can know what the significance of 384,615 is. Anyway, that's it. That's all I have to say for 384,615 and how it appears within fractions involving 13 and multiples of 13.